Hello, programmers. So, today's lecture is all about the visuals and the graphics that your user is going to see in front of all of the stuff that we've already discussed as far as the programmer goes. So, chapter 14, the last chapter of this course, is going to introduce you into something called a swing component. We've done a little bit with GUI, just very basic, our J option pane, but today we're really going to go into the topic of what other things are out there as far as swing is concerned. So we are going to describe swing components. We're going to look at particularly a J frame, a J label, a J text field, J button, and a J check box. Sorry. A J combo box, and a button group. Button group doesn't have a J, don't know why. Within that, we're going to talk a little bit about a layout manager and how to make everything look pretty. And in order to use these swing components, we need to learn something called an event-driven programming and what an event listener is. And that is what is going to allow those swing components to actually do something when the user clicks it. Java has several different GUI front-end interfaces. The basic one that Java initially worked with was called an Abstract Windows Toolkit, or an AWT. It is an older framework. It only works at Windows, as you can see, because it's an Abstract Windows Toolkit. It was not as portable, and you weren't able to have the same look and feel across operating systems with it. So it also comprised of GUI components such as buttons, text field, other components which the user can interact with. Remember, we're talking front end at this point. Java created something called a swing component. It is a part of the Java Foundation classes, and it is a descendant of J component. Okay, everything that is a swing component is a J component. You do have to, there is a new method, an import statement that we have to use. You do have to do an import java x.swing.star. We saw that when we used our J option pane. Okay, and it inherits everything from the Java AWT container class. So as a container, it holds something, and remember, front end. There are two different types of components. There are lightweight components and heavyweight components. Your lightweight components are going to be operating system independent. They will look pretty much the same across operating systems, and it doesn't matter where you're running it. Heavyweight components, on the other hand, do interact with operating systems, and they're going to look a little different whether they're being run on Windows or iOS or Unix. Swing components are containers. It is a type of component that's going to hold other components. It also gives the ability to allow a group to be treated as a single entity, such as radio buttons. They are defined in the container class, and the base often takes shape of a window, such as our J option pane. Within this window, we can do some basic tasks. We can drag, we can resize, minimize, restore, and close. All of these are already built into that container. Now, a window class of swing is a child of a container. It does not have the title bars or the borders. You're rarely going to use it. Instead, we tend to use a frame or a J-frame. So let's look at J-frame a little bit closer. So you can create a J-frame so that you can put other objects within it for display for that front-end user. We're going to have an example of what it looks like here in just a second. Your J-frame is going to have 4 different constructors, and you can see here the relationship of J-frame back to your component container and window, and eventually back to object. So you've got 4 different ways to construct a J-frame. You have your empty constructor, or your default constructor. You can send it a string, which becomes the title of the J-frame. You can send it a graphics configuration, which is a little bit beyond what we're going to look at. Or you can send it the title and the graphics configuration, like on that last line. This is an example of what a J-frame is going to look like. So the J-frame itself is actually just this gray box, okay, within the window. All of these other items are going to be J text boxes and things and J buttons. So that's why you can see it's a container. It is something that is going to hold something else. Some typical J-frame methods that we use: set title, set size, get title, set resizable. If you do not want your window to be resized by the user, you can set that to false. You can get if it is resizable, and a very important one is a set visible. So when we create them, you have to make sure we set them visible. And then finally, we have a set bounds, which is going to allow you to put your window wherever you would like it. Now, in order to use the JFrame class, we're going to have to create a JFrame, and we do so by doing a constructor just like we do any other object. JFrame first frame equals new JFrame. We're going to use the constructor that takes the title here. So we're going to have it as a title that says hello. Okay, and in this example, it says first frame. We can set the size and the title in a different way. Okay, we can say first frame dot set size and give it pixels. Okay, X and Y pixels, number of pixels. And we can also change the title here. First frame dot set title my frame. So here it turns it to my frame. One thing again that you always do have to remember is to set visible equal to true, otherwise it won't be seen by your user. To close the JFrame, you can just click on the close button. This is the default behavior. So your JFrame is going to become hidden and your application is going to keep running. Okay, so in essence, your close button is setting that visible to false. You can change that if you would like, and by using the set default close operation method, you can override that method, and if the close button is clicked, you can do something else. You can also customize a JFrame's appearance. So window decorations, icons, buttons, you can do set default look and feel. Okay, the look and feel is going to be a default appearance and behavior of a user interface. So this default is based on operating system. It's going to look and feel and act one way if it is working on Windows, and a completely separate way if you're working on an iOS. For example, the big difference that most people notice is that your minimize, maximize, and close buttons are on opposite sides. It's on the right for the Windows, it's on the left for iOS. Using this set default look and feel, it will take whatever the default is, and it's going to give you that operating system look and feel in the end. The next class we're going to look at is something called a JLabel. A JLabel is just going to be plain text. Okay, it's just going to output words, nothing else. There are 6 different ways you can do it. You can look them all up if you would like to. Most of the times it's a JLabel and you send it a string as to what you want their text to look like. Some methods that are used quite often with JLabel is an add method, a remove, set text, and get text. So get is, you want to see what is already in there. Set is to give it a new name, and then you also have add and remove. You can change things in your JLabel, such as the font. There is a font class. It's going to create an object that's going to have the typeface and size information. To construct that font object, you're going to need the typeface, the style, and the point size. Okay, so here, this example, it is right here. New font, Arial, bold, 36. Okay, then when you create that font, you need to set the font to the font you created. Okay, when you do a set font, it wants to see a font, a capital F font. Capital F font is in a java.awt, like you can see right here. And so you need to make sure you import that as well if you're going to change the font from whatever the operating system default font is. You can use something in Java called a layout manager. A layout manager is going to control where all of these components are going within your window. There's something called a border layout, which is the normal default behavior of the JFrame. It divides the container into regions, almost like dividing it up into a table. And then what you can do is put items in specific locations within that region of the container, or say cell of the table. There is something called a flow layout manager, and that is going to place your components all within a row, one right after the other, sort of when you're in Word and you don't put like wrapping text, things like that. You can extend the JFrame class. So when you extend the JFrame, you have something sort of like here. Okay, you can set the JFrame's properties within that object constructor, so you don't have to use things like the set width and set size. If you want to always in your program have a frame that's going to be 300 by 120, you can create a whole new class extending the JFrame and setting the size within the constructor. When that JFrame child object is created, it's automatically given everything within the JFrame plus everything you specify. So you create that child using the word extend, just like we talked about a few lectures ago. First thing you have to do is call the parent and get all of the parent information by using that super. Again, this is identical to what we've done before when we talked about extending other classes. Next, there are things called JText fields and JButtons. These are also going to be additional components that we can add into that JFrame to receive information from the user. So far, everything we've done has just displayed information to the user. So let's see how we get information back. A JText field is going to be a component where a user can type a single line of text. Okay, there are several different constructors. You can have a constructor with a default string that's already in the text box. You can have it blank. You can have a text box length. So if you want to look at those, look them up in the book or in the API. Some of the methods that are used a lot are set text, get text, and set editable. Set editable allows you to change what's in the text box. Set text, put something in the text box. Get text gets what the user has already typed within the text box. We can also add a button. So in Swing, it is called a J button. It is a mouse click to make a selection. There are 5 different constructors for these, such as the string as to what text you want on your button. The methods that are usually used, get text and set text. Okay. We use a method called add to add that J button to the frame. Now, one big thing to note is that just because you added a J button into a frame, if a user clicks it, nothing's going to happen. We've not yet told the program what to do if the user presses that button. So you can have a button and it's not going to actually do anything quite yet. In order for that button to do something, we have to create something called an event. And so let's look at event-driven programming as a whole. So an event is when something happens, okay? So in our case of looking at the J button, the event is going to be the user clicks the button. There are other events such as you click a radio button, you choose a selection in a combo box, but let's just stay within the realm of that J button. An event-driven program is a program in which the user is going to initiate any number of events. Okay, so there might be even several buttons that might do different things. The source is considered the component which generated the event. If you have button 1, button 2, button 3, and user pushes button 2, the source is button 2. Because you can have buttons 1, 2, and 3 do 3 completely different things. In Java, we have to implement something called a listener. So the listener is the object that's interested in the event. You have to tell the button in order to listen for a user action. Okay, in order to do that in Java, we call that registering the object as a listener. In order for your program to respond to a user event, you have to do a few different things within your class first. So first, you're going to have to prepare your class to accept event messages. So your class has to know what to do if an event is happening. Okay, tell your class to expect events to happen. So your class has to be aware that it needs to be listening and that something is going to happen and it will have to do something. And then finally, you're going to have to tell that class how to respond to the actual event. Okay, so prepare Okay, listen and then respond. Prepare, listen, respond. So first, prepare your class to accept event messages. You have to import a new package. There is a package called java.awt event. That is the package that you want to see at the top of your code. Then you're going to have to implement an action listener. So in your class header, you have to have implements action listener. Okay, implementing that action listener, that is going to give you just some basic standard event method specifications that is going to allow your listener to work with something called an action event. Okay, so this is the whole setup. Okay, telling your class to expect events to happen, you have to add that action listener to the component you want to listen to. There is a method called add action listener, and what you do is in any component, you do that component, say a button, add action listener, this. This is going to cause an action event message or a button click, right? Any kind of event that's going to come from this component, which in our case is a button, to be sent to this current object. Okay, because this current object is going to know what to do when we have that event. Finally, we're going to respond. Okay, the action listener interface is going to have something called an action performed where it is sent the action. This is called the event handler. So you have an event, which is the action, you have the listener, which is going to detect that event, and now we have something called an event handler that is going to tell us what to do when we have that event. The body of the method contains any statements that you want to execute when an action happens. When you've got more than one component in a JFrame, it might be necessary to determine which component did the action performed. Okay, if you need to find the source, so you need to find which button created the action, you can do something called a get source. That's going to tell you which button did the action. Now, a lot of programmers might do something like each type of button is going to have a different class, and then you don't need things such as get source. So those are kind of nice things that you can build into your programs. This code is showing an event-driven program. So here is my extends a JFrame. Okay, here's my new, don't forget your imports, and implements action listener. That is what is going to tell this class that it's going to have to listen for something. Okay. Also, within that, we've got an action performed. This is a method that we're going to override, and anything that we want to do once the button is clicked, we're going to put in here. So here, it's going to get the text out of, let's see, answer. Answer is a text field. Okay, so it's going to get the name out of the text field. It's going to say hello name, and then it's going to set the text of a label, a JLabel, to say hello and then the person's first name. So that's what's going to happen when the button is pressed. Okay, so you can see how really in order to create your button to do anything that you want it to do, it just says implements action listener, don't forget your import, and then override your action performed. Now, you can add more than one event source to a listener. So say here we've got two different buttons. You can use a JFrame that's going to react to the two different buttons. So here's my action performed, object get source. This is what's going to tell me which button actually created the event. If the source is option 1, then it's going to execute for option 1. Otherwise, it's going to be option 2. Okay, this is just saying that there's 2. The other way that you can do it is you can use that instance of to determine the source. So if source instance of text field, it's going to do something else. Typically, this one, the first way is more popular, or you just create buttons that extend JButton and they know how to handle the events that they want to do themselves. Now, we have a method called setEnabled. The setEnabled method makes a component available or unavailable. So you can initially make your button disabled. Then once the user types into the text box, you can create change it to set enabled equal true, and then your button will allow to be clicked. It's used after a specific series of actions has taken place, and it allows your user to either use or not use any of those swing components. Swing event listeners, these are classes that respond to those user-initiated events, okay? They must implement an interface that deals with events called event listeners. There are many different types of listeners in Java, and each can handle a specific event type. A class can implement as many event listeners as it needs, so you can look for different things. And an event occurs every time a user types a character or clicks a mouse button. So let's look at a few different types of event listeners. There is something called an action listener, that's for a button click. You can have an adjustment, which is for a scroll bar. Change is a slider. Focus listener is a text field. So a text field can gain or lose focus, determined by whether the user is clicked in that text box or not clicked in that text box. There's an item listener, traditionally used for check boxes. I have such a hard time with that word today. There are key listeners when listening for a keyboard click, mouse listeners, mouse clicks, mouse rolls, and finally a window listener, which is going to listen for a window close. So you can see you can have different types of listeners based on your type of component. Some swing event listeners, what it's going to do is it creates a relationship between that component and the class. Okay, so the component JCheckBox is going to respond to a user click. So if you add the item listener method, you're going to register the JCheckBox as a type of object that has an item event. And so you're going to have the source of the event add listener method. Okay. Add listener method is our new portion of that. So the listener registering methods, here's a list of components and the different listeners that you can have with them. So again, for action, you can actually have an action on a button, a checkbox, combo box, text field, or a radio button. All swing components have focus, key, and mouse listeners. And your buttons, checkboxes, and combo boxes and radio buttons also have item listeners. So the main thing to notice here is just that one component is not going to have one type of listener. So you need to understand what you want your user to do and when you want to do something based on that action and what that action is. So do I want a focus or a key or a window? So swing event listeners, the class of objects that's going to respond to this event contains a method. It's going to accept the event object created by that user action. Okay, remember, specific methods react to specific events. We just saw that, right? Clicks versus focus. If you declare a class that handles an event, create a class to do one of the following: either implement a listener interface or extend a class that's going to implement that interface. Okay, so either you need to do it yourself or you need to borrow from somebody else. If you declare a class that extends MyFrame, you need not to include the implements. Okay, I'm going to say that one again. If you declare a class that extends MyFrame, you don't have to do the implements there. Because you're extending the JFrame, the JFrame already has, or the MyFrame, it already has the item listener in it. Okay, you are going to have to register each instance of the event handling class as a listener for one or more components. Let's look at using the JCheckBox, button group, and JComboBox. So besides your buttons and text fields, there are several other things that you can do in your front end of your program. We have something called a radio button, and we have a checkbox. You can see here the difference. The radio button is round, checkboxes are square. Typically, radio buttons allow you to have only one choice out of what is given to you, and checkboxes allow multiple. Let's take a quick look at the JCheckBox class first. So JCheckBox, it's going to be a checkbox consisting of a label positioned next to a square. Your user is going to want to click the square to display or remove a checkbox, and it allows typically a turn on or turn off. So different constructors, you have an empty constructor, you actually have a constructor that has a title and a constructor that has a title and whether you want it to be checked or not. Now some methods: get text, set text. We've got set selected or is selected. The main methods that you want to be concerned about is the set selected and is selected. So set selected true will put a checkbox in anything, and a set selected false will clear out the checkboxes out of your checkbox. Is selected is going to tell you whether the user has put a checkbox into that checkbox or not. So the JCheckbox class, there are a few different methods. Again, your set text, your set selected, and your is selected. When the status of the checkbox changes, it actually creates an item event. Because it's an item event, you're going to need an item state change. That is what is going to execute once the checkbox changes from either checked to unchecked or unchecked to checked. Either way. Now, the button group class, this is going to group several different components so that the user can only select one at a time. So if you group JCheckboxes objects, all of the other checkboxes are automatically turned off when the user selects one. That allows for only one selection as opposed to multiple selections. To create a button group, and first what you're going to have to do is create your group and then add your components to it. So you create a button group by saying button group, new button group, just like any other constructor. Then you have your checkbox, and what you do is in your group, you're going to add a component. Okay, so that's going to be your steps in order to create the button group class. Now, last, we're going to talk about something called a JCombo box. A JCombo box is going to be one of those things where it looks just like a pull down. You click on it and it shows you your other options. I'm sure we've all experienced these as users. Okay, so it's going to combine two different things. There is a default option chosen, or whatever the user chose, as opposed to a list box that is going to give you alternates. So when your user is going to click your JCombo box, you're going to have all those alternates drop down. If it is selected, one of the alternates are selected, then this default display is what the user selected. To build it, you do a constructor with no arguments and then add each of the items with an add item method. So what you can do is JCombo box equals new JCombo box blank, and then do major choice dot add item English, add item math, add item sociology. The other way to do it is to use an array of objects as with your constructor. So if I make an array of string of the different choices that I want, I can then create the JCombo box sending it the array, and it will create an item for English, one for math, one for sociology. Class methods that are available in JCombo box: add item, remove all, get the item at. So this is going to treat it as if it were an array per se, and it's going to get the index position of a specific item. Get item count, so it's how many items are in your list. Get maximum row count, get selected, okay? Get selected index, get selected item, get selected object. So you've got three different ways to get what the user has chosen. Set editable, set maximum row count, set selected item, set selected index. So the set selected item and set selected index is going to be what the default is going to be for that user. So again, your set selected item or set selected index, you're going to have to choose something to be the default. Typically, it's usually the first one at the top, the 0, the most common one. Then you use your get selected item or get selected index to figure out which one is currently chosen. Again, we treat the items in the list as an array where your first item is at 0, your second item is at 1. So the index that you're getting, remember to always start at 0. Now, don't forget the X in the Java Xswing when you're importing. That's different than our typical java.awt. Don't forget to use the set visible on your JFrame if you actually want to see it. Don't forget the set layout when you have multiple components. Don't forget you can call something called a validate and repaint. So as you add or remove components and you want to refresh that window, you need to validate and repaint. You can use an item state changed. It's going to execute when an item event is generated. And don't forget that creating a button group, it doesn't cause the components to be grouped per se. Each component that should be in the group must be added one by one, but what it's going to do is only allow one of those items in that button group to be active at one time. And then don't forget, for some reason, button group doesn't have a J. That's all there is to swing components in that front end of the GUI. I really enjoyed this class with all of you, and again, I'm always available for email, whether it's within this class or without. I'm available to you for anything. So again, and for the last time, happy programming.